Okay, now we've moved the programming wires off. We've moved the 5 volt to the 3.3 because the circuit should be running on 3. We've hooked up a current meter again to monitor everything. We've hooked up the MOSFET back, so we've disconnected the short between the drain and the source and put that back in there. So basically the C8 signal from the Digimon turning the screen on is going to be this blue wire here, and all I have to do to turn this circuit on is give that blue signal some 5 volts. So we'll just move the rail up and down to turn that signal on. Over here we have the button to stimulate the C button. Again, I push down the button just like the C button. It's going to give a 5 volt signal, and that will go into the chip. The last thing we got to understand is the sound signal is going to be grounded, but slightly separated in the Digimon. It's yeah, so we will disconnect it whenever the screen goes off, if that makes sense. Over here we have hooked up the negative rail to the LEDs, and lastly we hooked up the reset, because again, remove it for programming but put it in when the programming wire is out. The capacitor has been removed due to we're no longer programming. It doesn't matter about the reset on either or this unit here. If you don't have the MOSFET, you will basically have the same function, except you won't be able to control the C8 sort of function until you either solder that part into the circuit, etc. Okay, so as we can see, we have 0 volts, and yet this circuit is powered. So it is as if it's sitting in the Digimon right now, fully powered up. The only thing that it needs to do is it waits for this signal here, which is going from the C8. So let's give it some 5 volts as if the C8 just turned on. And the first thing you'll notice is the chip now has current, nice low current, because it is at 1 megahertz instead of 8. As well, nothing's happening other than it's just looping through its program, waiting for some sort of signals. Now, if we quickly turn the display off, the chip would also then turn off. And if you want, we can quickly check just to prove. We're looking at 7 microamps for this circuit when the screen is giving it 0 volts. So when the screen decides though to give it some voltage, we all of a sudden have the chip turning on. One of the things that we must do is also have the sound hooked up, and we can then see, yes, the current is only 1 and nothing is running. Now, for default, backlight stays off, sound signal is red. So if we pull the sound signal off the ground, we immediately start seeing some red. Obviously some current starts going through, and if the frequency is bouncing, the signal will go like this, giving you a nice pulse, matching the sound effects of whatever the Digimon's doing. If you want backlight, you hold down the button for just over a second, or just under a second, sorry, and you can increase the brightness as well by doing so. It'll cycle through 5 different settings and then back to off, and you can do this in a loop consecutively. The third function is triple tap, so 1, 2, 3. And now you've changed the way the sound works. The sound will no longer do red and only flashes on and off the backlight. You hit it 3 more times and the chip will not respond at all to any sound effects. But it still does have its backlight effect. So let's say we turn on the backlight. There we go, we got second level backlight and sound, nothing happens. Doesn't matter if the sound is on or off, just backlight. So again, triple tap, run through those settings. This is where both lights are going to work, or just the one light, or just the red light if the backlight's off. And I can quickly show you that. Backlight goes off. Now we just get red light if we have sound. Backlight on, and they're both going to alternate when they get sound. Now let's say we don't want the red. 1, 2, 3. Now you're just going to have the backlight flashing off and on for sound. Or you can actually, if the backlight's off, you can have the backlight flash on and off for the sound. Again, giving you some different effects during playing. Might be some fun to play around with. And then the last thing to keep in mind is, let's say this is set and this is set. Okay, so they're both set to just second intensity, and right now no red light. Well, when the screen goes off, the chip goes off, and the chip will not hold its memory, which is a good thing, because the chip is set to basically have defaults, so that the backlight, every time you turn the backlight on, it doesn't just automatically come on. You can demand it on it, etc. But the sound effects are programmed to stay on all the time with the red light, which is a very nice effect, but can be changed if you wish to when programming. There is a small section in the program where you can adjust the default settings for when the screen turns on. This has to be done when programming the chip, cannot be done after. So keep that in mind, especially when doing a pre-order, on how the defaults of when the screen turns on, how that is going to affect the settings. Let's see if I can quickly demonstrate that now. So if I put this back in, the chip has come on. Originally we had the backlight on and the sound was no red. What's going to happen right now is red is immediately going to be coming back, and the backlight has been reset. Now this will pretty much be the default. You can do it again. We'll quickly turn off the whole chip, give it a second or two as if the screen's been off now, and reconnect. And once we're reconnected, you can then it's this. Okay, so if I remove this rail, there we go. Yeah, the sound speakers, it's odd when I go to mess around with this, I have to make sure that I lift the sound when I turn it off anyways. So that way we always have a reset, because again, that's how it's going to work on the Digimon. This wire and this wire both are going to be disconnecting at the same time. So when this one goes here, this one's supposed to go here, and now it's completely off. When it goes back on again, this one would go here, this one would go here, and nothing would pulse unless there was sound. Then it would start pulsing. Now you can tie this to either rail. It's not really a matter. What this is actually measuring is the slopes or up downs, not actually measuring any voltage. It's measuring changes of voltage. But because the Dig is going to be hooked up on the negative rail, We just use the negative rail. It looks good that way. One thing to keep in mind, if you do not use a capacitor, you might have some issues with a lot of drainage current going down the negative rail. Pins like to be held high, and if you hold them low, current will leak. I think that is it. I can quickly demonstrate the current if I operate it. So here we go. We're going to get up to a high intensity. Oops, I passed it. 1, 2, 3, 4, 5. All right, so that's at max intensity. Now, it's putting out 20 milliamps. We're going to be getting a lot better LEDs soon too, that are way more efficient. And because originally our LEDs were only taking up around 1 or 2. These are old school just testers. As well, right now we're running at 3.3. We're going to be lowering that by at least a 0.5. Okay, that's just under 20% or so. But that will lower this. Okay, so that'll bring that down quite a bit. And then yeah, if we're flashing, so yeah, we do have some. Now the other neat thing is what I can show you later on the bench, if you want, is the reason we're using yellow and white, or I mean yellow and red instead of white and other colors, is because of the voltage drop across LEDs to get the best lighting effect while the battery drains or gets really low. Yellow and red are recommended or selected for this. At which point, yes, this circuit can literally run at 2 volts and still give you relatively decent current, relatively bright LEDs, light. So yeah, it should work. We'll now take this off, or I'll take that chip out of there, and I'm going to start installing that chip onto a board, and you can see how that is done.